if you have two matrices that you're going to be multiplying together, so if matrix A was, let's say, an M by N matrix, and matrix B was an N by R matrix, are we able to multiply them together? Yes, and we're able to multiply them together because these are the same thing. They're both N's. So when you multiply them both together, the resulting matrix is the first of the A and then the last of the B. So it would be an M by R matrix. Okay, so this is just putting it into words if you want to write that. You can only multiply matrices if the number of columns of the first matrix is the same as the number of rows in the second matrix, which is what we were saying yesterday. That's just putting it into words. Okay, so the number of columns of the first needs to match up with the number of rows in the second. Thank you. Have a seat wherever. So if we think about dimensions of matrices, if I had a, let's say, 3 by 3, can I multiply that with a 3 by 1? What would be the resulting product? It would be a 3 by 1. Could I multiply it by a 2 by 3? No, because this number of columns does not match up with that number of rows. What if I had a 4 by 1 times a 1 by 4? Is that possible? Yes, what would be the resulting matrix? It would be a 4 by 4, right? Okay, so let's go ahead and actually do the one that we did yesterday, but you didn't probably put it in your notes. So if we had a 2 by 2 times a 2 by 2, what will be the product of 2 by 2 by a 2 by 2? Another 2 by 2, right? Okay. 2 by 2. Good? All right. So if we had H was the matrix 2, -3, 1, and 5, and G is 6, 0, 4, 7. We want to find HG. And all of these multiplication problems are going to say if it exists. And the reason why it's asking if it exists, because if it doesn't exist, then you can't find the product. But this case it does, because this is a 2 by 2. This is a 2 by 2. Your rows and columns match up, so we're good to go. So what did we do yesterday? Do we remember? So what I like to do is I like to find what the resulting matrix is going to be and kind of put my 2 by 2 blanks there. So how do I find the element for row 1, column 1? Yeah, I'm going to take row 1 of the first, and I'm going to blend it with column 1 of the second. So we're literally going to take the 2 and the -3 and match it up over here. So this 2 is going to get multiplied with that 6. And if you get good with it, then you can just not write out all these steps. And then I'm going to take the -3, and I'm going to multiply it with the 4. And then I'm going to add those two products together. Well, 2 times 6 is 12. -3 times 4 is -12. 12 plus a -12 ends up getting us a 0. So my actual matrix is just going to have a 0 there. So now to get row 1, column 2, I'm going to combine row 1 with column 2 over here to get this element. So I'm going to take that 2 and I'm going to multiply it by 0. So 2 times 0. I'm going to take that -3 and multiply it by 7. And then we add them together, and then, yeah, we get -21. So my element in row 2, column 2 is -21. So now we're in row 2. So to find row 2, column 1, I'm going to focus on my row 2 and combine it with my column 1. So the 1's going to multiply with what? 6. And the 5 with 4. So 1 times 6 is 6, plus 20 gets us 26. To get row 2, column 2, I'm going to take row 2, combine it with column 2. So 1 times 0 plus 5 times 7, which gets us 35. So there would be our answer. So there would be your HG. Would GH be the same? Well, let's figure it out. What would it be? See if you can do GH on your own. So usually what I like to do is if I had to find GH, I literally will rewrite the matrices so that G is first and H is second, because that just helps me out for my processing and the order of everything. You might not necessarily need to do that, but for me it helps. So see if you can find the product of GH. See if you agree with mine when you get there. Hopefully I did it right. So you will come to notice when you do set it up like this, notice the numbers in your parentheses. Here I have 2, here I have 1. Well, where does the 2 and the 1 come from? Column 1. They both are in column 1. Negative 3, 5. Where do they come from? They're both in column 2. Then look here. 6 and 0, 6 and 0. Where did they come from? Row 1. 4 and 7, 4 and 7. Where did they come from? Row 2. So you get your rows from the first matrix, and you get your columns from the second matrix, which kind of helps with the way that looks. Okay? All right. So far we're doing all right. Can we multiply these two matrices together? You don't have to write it down, just look. This would be a what? 3 by 2, and this would be a 2 by 2. Can we multiply them? Yes. What would be the resulting matrix? 3 by 2. All right. So again, what I like to do, I have 3 rows, 2 columns. Remember, it's row by column. Is I like to set it up with my resulting matrix because it kind of helps me to see where it is that I'm going. Oh, hold on. We can't do this. That's not a 3 by 2. What is that? 2 by 3. I was just going to say, that's a 2 by 3. That's not going to work. Why wouldn't it work? If I take this row and match it up with this column, do I have each of these elements matching up with an element over there? No. No. So I can't do that, so that's not possible. I can only name the elements or the ones correctly. Okay, so you have to pay attention to the dimensions. All right, so the last thing we need to do is a lovely word problem using matrices and multiplication. So, we've got student council selling flowers for Mother's Day. Very nice of them. They bought 200 roses, 150 daffodils, and 100 orchids for the purchase prices shown. They sold all the flowers for sales prices shown. Organize the data into two matrices and use matrix multiplication to find the total amount that was spent on flowers. All right, so what do we think these matrices will look like? Well, we need two matrices.
One for what they the price they purchased for.
Yep.
And one for how much they sold it for.
Good. So, let's do that. We're going to have, let's start writing. We're going to have a purchase price matrix. And we're going to have a sales price matrix. Okay. What else? Well, we're probably going to have the purchase price for a rose. Probably going to have a purchase price for a daffodil. And an orchid. Same thing for over here. I'm just going to write it on the other side because I'm kind of running out of, well, I guess I could squeeze it in there. So we had rose, daffodil, I'm just going to put daff, and orchid. All right, so what are my numbers going to be? Well, so now we need to decide, did I only buy one rose? No, how many roses did I really buy? 200, so what's 200 times 1.67? Who can help me? 200 and some. Don't worry, guys. I've got it. 1.67 times 200. 334. Okay. Daffodils. How many do we have there? 150 times 1.03. 0.5. Orchids. 100. That's easy. 259. Huh? Sales price. So how much money am I making off my roses? So 200 times 3, $600 we make off of roses.
Nice.
How much? 150 for 225. 337.50. And orchids, 450 times 100. I don't know why I even did that. 450. Okay. Yeah, we should do the flower business, huh? So here's my purchase price. Here's my sales price. So what would I do with these two matrices if I wanted to know what my profit would be? Subtract sales from purchase? Yeah, subtract sales from, or sales minus purchase, I think is what part A is going to be. So if we do, can I erase this? So if we do, I'm going to do S minus purchase. What would that get me? So S minus P. Now I just lost it. What would be the first element in the column? Is that what it is? 360? I'm going with it because I erased it and I don't have any. 268. Well, it should have been what? All right. Let me bring it back. 600 minus 3 is 266. 337.50 minus 154.50. It's 183. 450 minus 259. It's 191. All right, so now I got it. So the product, or the difference, would be 266, 183, 191. How could you then find your total profit?
Add those together.
Yeah, so 266 plus 183 plus 191 gets us to 640. Okay. All right, matrix multiplication, matrix addition.